Let's take a look at the idea of factoring and common factors. Factoring, it's kind of the opposite of multiplying out an expression. So a factored expression, for example, would be like 3x squared times 7x to the third power plus 10x. So this expression is factored because it's split up into two parts that are multiplied together. Right, so in general, factors are separated by multiplication or division. So, if we start with a factored expression, I could multiply that out. The parentheses tell me that the 3x squared should multiply with 7x cubed and also with 10x. So I can distribute. And so we'd end up with 21x to the fifth, multiplying the numbers in front, multiplying the coefficients and adding the exponents, plus 30x cubed. X cubed. The idea of factoring is to kind of do things in the opposite order. So, for example, we might have an expression like 24a squared plus 60a. So if I start with an expression that looks like that, so this expression is kind of in the expanded form, I would want to figure out how to turn that into a factored form. So given something in an expanded form, there are two things I want to look at. I want to look at the numbers in front and also the variable part. So the numbers in front, of course, are called the coefficients, and the variables are the variables. So looking at the numbers in front, I want to think about, is there a number that divides into both of those? So, this can be a little bit of a challenge. I'll post a separate video that describes a little bit more about how to find what number works. But looking at these numbers, you may think 6 divides into both of those, which is true. So 6 divides into 24. 24 is 6 times 4. And 6 divides into 60. 60 is equal to 6 times 10. So, we can tackle this in stages. One stage we might see, I can factor out a 6. And then what's left behind? Well, we just said 24 is 6 times 4, so that would be 4a squared. 60 is 6 times 10, so that would become 10 times a. But now, looking at the numbers that are left behind, there's also, those are both even, so there would be another factor of 2 that divides into 4 and also into 10. So I could write this as 6 times 2, and then what's left behind is 2a squared plus 5 times a. Since 4 is 2 times 2, and 10 is 5 times 2. So putting these together, because they're just numbers being multiplied together, so I could turn that into a 12. But now looking at what's left behind, a represents some number. I don't necessarily know what it is, but a represents some number. I have in the first part of the expression a squared, so this would be a times a, and the second part of the expression is just 1a, and so I can factor out an a. Right? So since both of these terms, terms are things that are separated by addition and subtraction, both terms have a as a factor. Since the first term has a squared in it, if I factor out an a, there's still 1a left behind with that term. So this would be 2 times a. The second term just has a single a, so when I factor out the a, there's just a 5 left behind. So this would then be the factored form that's equivalent to the expanded form that we started with. So the idea of a common factor becomes important. So I would say, if I look at these two terms, the 12a represents a common factor, and in fact it's called the greatest common factor of the two terms that I started with, of 24a squared and 60a. So if we want to think about how to get from that first step to the last step, getting from the expanded form to the factored form, as quickly as possible, identifying a greatest common factor is what we want to do. In another video, I'll take a look at a bunch of examples of factoring out the greatest common factor. I hope you enjoyed the video. Thanks for watching.